Morning to all of you. Morning to all of you. As usual, I want to show a very all about it, trying to understand line. So here, what all operator. So you have, so what is this? Here, actually, imbalance. They use the paper wala use it. So you have a imbalance. One end of the balance. Four into 50. Look at the other end of got one more wire coming through another LED. That is also connected to the 200. So I have now look. So got two masses. 100 grams, 200 grams, and the two ends of the. Now I want you. What will reading? What is the mass or the weight measured by this balance? There is one end, 200 grams, and what will be the here? Okay. I will give you some options. Because you are all trained. That's the option. What is the option? A. So I've got 0. Plus 1 4 here, 1 4. B. 200. 400 grams. Second option. Third option is 200 grams. And the fourth option is none of the above. 200 grams here on either side through the almost frictionless pulley, and it is a spring balance. Now you have to tell me whether the answer is A or B. A is 0 grams. Read 0 grams. B, it will read 200 grams. Sorry, 400 grams. C, it will read 200 grams. D, none of the above. Anybody can guess? Now I tell you. Most of you may think that because there are two equal opposite forces, it should be 0. Others will think there are two forces, so the spring will be extended appropriately and therefore it should be reading 400 grams. But the reality is it will read 200 grams. So I can assure you, I am able to see here the reading. You may not be able to read from there unless we zoom in. This is 200 grams. It reads 200 grams. But how do you understand that? You can understand it very easily by knowing what normally we do with the spring balance. So I have the spring balance. Now I will disconnect this. Now I want to remove one end. This is a normal spring balance as we normally use, and I connect one of the mass 200 grams. Now what will be the reading? This is only 200 grams mass. What will be the reading? You all know that this will read 200. Okay, but what is my hand doing? My hand is giving a reaction force here. So that this is all in stationary. It is all in equilibrium. So I give a reaction here. Do you know how much is the reaction force? It must be equal to mg. Therefore, here I should give 200 gram weight force to balance this 200 grams weight. Then this now will read 200 grams. He reads only by making use of the extension of the spring, and the elastic force of the spring is a reaction. It is now conveyed to my hand. Therefore, it should read 200 only when I give another 200 gram force on this side. That is what I did by using another pulley here. So the reading should be only 200 grams, not 0, not 400 grams. I hope you understand it. It's a very simple, nice experiment to clear some small misconceptions that we normally have in such things. It would be nice if I could interact with you and ask you such questions and you answer. So I hope you enjoyed this. Now we will move on. I realize that we have already done 3 lectures and most of them are some basic vector algebra, and yesterday I talked about the rotation matrix, how vectors preserve their magnitude and direction on their transformation, either translational or rotation. And then I derived the rotation matrix, okay. And now we want to continue and go on to another coordinate system. Okay, we need to have other coordinate systems depending on the symmetry of the problem. Okay. So for example, we are now familiar with one coordinate system, which is our Cartesian coordinate system or rectangular coordinate system. That's what we normally call it. So this is x, y, z, and it is 90 degrees between each one of them, and you have a unit vector ex, you have this is ex, and this is ey, and this is ez, or which we normally call as ijk, more familiar perhaps with ijk, but I normally use ex, ey, ez. So ex, ey, ez are the directions. Unit vectors are basically direction vectors. They don't have magnitude. The magnitude is 1. And this is our x, y, z coordinate. We are very familiar with these. We have done a lot of problems earlier in your school and all that. Now we also can have, if there is a point P here, I specify the point by using the 3 components x, y, z. That means I need to go x units. So for example, I have to drop so I have to come x unit, then I have to go y unit parallel to y axis, and I have to go z unit parallel to z. This distance is z, this distance is x, and this distance is y, and this is equal to this. Therefore, x unit, y unit, z unit. If I go, I will come to the point P. We all know this. Now I can do one other thing. I can join this. What is this called? The position vector. Okay. I want to call this as, instead of r, I want to call this as a vector rho. Okay. This is my rho vector. And I want to specify this angle as phi. What is that angle phi? The angle phi is the angle which it makes with this axis. This I consider as a 0 axis. Okay. Now for simplicity, maybe at the beginning I don't want to have x, y, z. Okay. I will just take only, let me redraw that. I want to take only 2-dimensional situation. So I have only 2 axes. I call this x axis, this is y axis. The point P is there, and this I call rho, and this has got x and y. Now 2-dimensional in a plane, and this angle is phi, and I call this origin. I have of course ex and ey. So I take the 2-dimensional case. Now this point can also be reached by using this vector and turning through an angle phi from the x-axis. I assume x-axis to the 0 reading for the angle, 0 radians. So I move by 5 and then reach. So you can see that this same point can also be specified by 2 other components. They are rho and phi. So this is a polar vector, therefore it is called polar coordinates. You can see just as any point in this plane I can reach using x and y coordinates, my rectangular coordinates, any point. So what will be the limits of my x and y? So you know that x and y should be greater than or equal to minus infinity and less than, I hope you understand the symbol. What I mean by that, x and y should be greater than minus infinity and less than plus infinity. That means from this infinity to that infinity, this minus side, plus side y, minus side y, I can cover every point in this infinite plane which is parallel to the board. Can I do that same with rho and phi? Yes. What about the limits of rho? Rho starts from this point, origin, 0, and it can go up to infinity. So 0, this will be the range for rho. Then you are worried about the points on this side. But that can be covered by my phi. The phi can go from 0 full circle. That means it can have 0 to 2 pi. So 0 this will be the range for my phi. So having these limits specified, you can find that rho phi is as good as xy in positioning any particle in this infinite plane. Okay, so this could be a coordinate system, plane polar coordinate. So it becomes a plane polar coordinates. Now let us study about them. If I have a plane polar coordinates, then I must also define, just as my Ex and Ey, some two unit vectors which specify the direction of rho, in which direction rho is increasing, in which direction phi is increasing. So now how do I specify? I can specify this is the rho increasing direction. Therefore, I can put a small unit vector, call it E rho. E rho is the direction corresponding to rho increasing, and the magnitude is 1, and it is a unit vector. Its magnitude is 1, therefore it is a unit vector. So what about phi? You have to take phi increasing. Phi increasing will be like that. Therefore, it has to be tangential. So that will be the direction of E phi, unit vector along phi increasing direction. So you have two unit vectors, E rho in the direction of rho increasing, E phi in the direction of phi increasing. Luckily for us, you can see this is the radius vector, this is tangential, therefore this angle is also 90 degrees. So the angle between E rho and E phi is 90 degrees. Immediately the moment I say that, you know what is Ex dot Ex is equal to. What is Ex dot Ex? This is the dot product. Magnitude of Ex into cos theta, which is theta between Ex and Ex. What is the theta between Ex and Ex? 0. So cos 0 is 1. This is 1. This is 1. Therefore, the value is 1. This is true of Ey dot Ey, Ez dot Ez when you have the Z component also. Now we are looking only at two components. Then you also know what is Ex dot Ey. What is Ex dot Ey? Magnitude of Ex 1, magnitude of Ex 1, and the angle between them is 90. So 1 into 1 cos 90. What is cos 90? Everybody knows cos 90 is 0. Therefore, this will be 0. So we know this. We can obtain similar relationship between E rho and E phi. Now tell me what is E rho dot 0. What is 0 dot 0 and what is E5 dot E5? 1 into 1 angle between 0 and 0, that is 0. So this is 1. This is also 1. Therefore this value is 1. What about 0 dot E5? You know, 1 into cos angle between them, cos 90, therefore this is 0. So just as you have here relationship between the Ex, Ey, similarly you have a relationship between E rho, E5. Okay, this you should remember. It is very easy to remember because they are orthogonal. Ex dot E rho dot E rho, E5 dot E5 should be equal to 1 and E rho dot E5 should be equal to 0 because 90 degrees coming there. Okay, having said all those things, if I want to represent any vector, say for example A, in rectangular coordinate system, how will you represent? You know that. I will assume Ax is a component of A along the x direction into Ex plus Ay, Ey plus Az, Ez. If it is a 3 dimension. Now we are considering only 2 dimension. I should keep on reminding myself. Therefore, I have to write only 2 digits. I am looking at plane. Aex, Ex, Ay, Ey. Ax and Ay are the projection components of A in the direction of X, in the direction of Y. How do you get it? I can get this by taking dot product between the unit vector and the vector. If I take Ex dot A, what will you get? Ex dot the whole thing. Ex plus Ay, Ey, and that will be equal to, we know, just now I wrote Ex dot Ex is 1, therefore this will be Ax, all the other things, and Ex dot Ey, because 90 degrees is there, this is 0, therefore nothing will be there. So if I want a projection in the direction of any of the coordinate axes, I have to take a dot product of that vector with the unit vector. Ex dot A gives me the projection Ax. Similarly, Ey dot A will be Ay, etc. I just want to indicate to you. But I want to represent the same vector in the new coordinate system, the plane polar coordinate system. How do I do that? So I will say, for example, A rho is a component of the vector A in the direction of rho. Then I have to multiply by the unit vector. Then A phi is a component of A in the direction of phi and multiplied by phi. Just as we write in this case, Ax, Ex, Ay, Ey, you can write. This is a general vector. But right now I am interested, for example, in the position vector. I want to know how to represent a position vector. Position vector is given by R. So what is R in rectangular coordinate system? X, Ex plus Y, Ey plus Ez, Ez. Sorry, 2 dimension. So I will take X and Y only. Okay? X, Y, Ey. If the same thing I want to write in my plane polar coordinate, what should I write? This is something tricky. If I want to write in plane polar coordinate, I have to say rho, because this is rho, the position of that, this distance is rho, and it is along the ER direction, E rho direction. So I put that. So the position vector in plane polar coordinate looks very odd. It has got only one term. There is no phi dependence. But it is not surprising. We should recognize the phi dependence comes in E rho. So it is a very interesting case where you find that if I find that time, what happens to Ex and Ey in the rectangular coordinate system? Ex and Ey will be constantly in the same direction, Ex and Ey. No worry. So if I perform any time rate of change of the unit vector dEx by dt, it is not changing. It is always in the same direction. Same with dEy by dt. But if you look at E rho, you find E rho is here. If the object starts moving in some direction, then you find I will have new lines coming for the different positions. That means my E rho is going to change. This unit vector is going to change at different points. Therefore, if the body is moving, not only the position vector changes, even the unit vector changes. Because E rho changes, automatically E phi also will change. It will always be perpendicular to each other. So as I move this radius vector over different angles, you will find both E rho and E phi will change. Therefore, E rho is a function of phi, depending on the phi. If this is E rho, the phi is different. If this is my E rho direction, the phi is different. So E rho is going to be a function of phi. Therefore, even though I have not explicitly written another term for phi, that is all contained here. So this is what we should remember. Now we should try to find the transformation. Whenever I have two coordinate system, I should immediately understand how to go from this coordinate system to that coordinate system and vice versa. So I must have some relationship which relates. For example, I can take E rho and E phi and write in terms of some Ex and Ey. I must be able to write what is the relationship between X and Y. So that will define. That is what I am going to do. Before I do that, you can immediately see what is the value of rho in terms of X and Y. What is the value of rho in terms of X and Y? Rho will be equal to, this is a right angle triangle. This is X, this is Y. Therefore, it is X square plus Y square square root. That is what rho is. Because this is a right angle triangle, this is my rho, this is my X, this is my Y. So rho of one coordinate system, the plane polar coordinate system, can be related to X and Y of the rectangular coordinate system this way. Similarly, I want to find what is my phi. What is my phi? I know tan phi is opposite side by adjacent side, Y by X. Therefore, I can write tan inverse Y by X. This will be the relationship between rho in terms of X and Y, phi in terms of X and Y. What about the opposite? How do I represent X and Y in terms of rho and phi? That also we can write. What is X in terms of rho? So this is X, this is rho, this is phi. If I project it onto this, it is rho cos phi. So rho cos phi is the X value. And what is this? That is rho sin phi. So this is the relationship between X, Y and rho phi on the reverse. So these two you should remember. There is nothing great about it. You can always recognize. Most of you would have recognized, so it's very simple. But now I want to go to a little extra value, and that is I want to relate the unit vectors. You have one unit vector Ex, another unit vector Ey from the rectangular coordinate system, and you have E rho along the rho direction, arbitrary rho direction, and because this is theta, so you have one more unit vector, I call this E phi. So this angle is phi, therefore this angle is also phi, because the angle between E rho, Ex and E rho is phi, and Ey is perpendicular to Ex, E phi is perpendicular to E rho, and therefore the line between the perpendiculars, the angle between the perpendiculars should also be the same. If this is phi, this is also phi. Once I know this, then I can immediately write the relationship between E phi, E rho, etc. So I want to say what is E rho is equal to. You yourself will tell me what is E rho in terms of Ex. So if I drop a perpendicular from here, just now we saw that it is nothing but I have to go this distance along Ex, which is, this is unit vector, so 1 into cos phi. So 1 into cos phi in along the Es direction I should go, then I am here. Then I should go this way. This is 1 into sin phi Ey plus 1 into sin phi Ey. So that one I need not worry. So you find E rho is nothing but cos phi Ex plus sin phi Ey. Now you have to help me find out what is E phi is equal to. E phi is in this direction. So I have to drop a perpendicular like this. If I drop a perpendicular like this angle is 90 minus phi, this small angle, right? If you want, I can draw a bigger picture. This is 90 minus phi, so this is cos 90 minus phi. So I will say, but it is in this direction, opposite to Ex. Therefore, I should put a minus cos 90 minus phi along the Ex direction, minus Ex direction, plus it is this one is sin 90 minus phi, okay, and that is along the Ey direction, sin 90 minus phi along the Ey direction, and that will become minus cos phi Ex, sorry, this is sin phi Ex plus cos phi Ey. So you find cos phi Ex sin phi Ey minus sin phi Ex cos phi Ey. The moment I write it, it looks something very familiar to you all, okay. We have just seen in the previous lecture that I can relate E rho, E phi as a vector, and I can write another matrix, transformation matrix, which we have done already. So these two equations I can write in the matrix form. This is a column vector, this is a 2 by 2 matrix. So now you can immediately recognize this matrix. What is this matrix? It is a rotation matrix, which we have already seen. So it is almost like I am rotating the coordinate system, right? So this is the relationship between Ex and Ey, and in a moment you will immediately guess if I want to write the reverse transformation. That means I want to write what is Ex, Ey in terms of E rho, E phi. If I want to write what is the matrix that I will write here, almost every one of you would have guessed, you can also derive. It will be the transpose of this. It is a reverse transformation. So it will be a transpose of that, and because I have already told you that this is a orthogonal matrix, the transpose is also the inverse. So you will find this will be cos phi minus sin phi sin phi cos phi. So you interchange these two and write that will be the inverse matrix, inverse of this. So this is equal to this divided by this, that is what you will do, which is equal to saying inverse of this matrix, you should multiply. The inverse of the matrix is obtained by just transposing it. Sin phi minus sin phi, you just transport, then this will be the relationship between 0 E phi. So you find you can find the relationship between Ex Ey and 0 E phi or 0 E phi and Ex Ey by this scheme. Still we are only with a two-dimensional case, and I can also write just as I have written in this form. I can also write, I will write here. I can write 0 in terms of only x and y. How do I do that? What is 0? 0 is, you can see 0 E phi Ex, this is 1. Okay, now I can or if I say x, this is x cos phi. Okay, so this is nothing but zero gives me the cos phi, the magnitude is cos phi, so that direction is that the direction will be obtained, the magnitude of this is x by root of, this is nothing but rho, you all know, rho is root of x square minus, x by rho is nothing but cos phi, so that gives me the magnitude. Similarly, E phi will be sin phi, and that will be y by x square plus y square. So this the relationship between Ex Ey in terms of the other two. Okay. Now we can try to understand little more about the plane polar coordinates. This is like a graph sheet. I have my origin here O. This is in my rectangular coordinate. This is my x, this is my y. Okay, I'll put arrow. Now, can you tell me what are these things? They are characterized by something. What is that? Similarly, what are these vertical lines? They are all x is equal to constant. The equation to these vertical lines are x equal to constant. For this line, x equal to 0 because it is at the origin. If it is, for example, 1 unit, if this is 2 unit, etc., this line is x equal to 1. If I connect all the points which are unit distance from this y-axis, I will get this line. So that line, equation to this line is nothing but x equal to 1. Equation to this line is x equal to 2, etc. Similarly, all these horizontal lines are y is equal to constant. The same way. So 1, 2, 3, 4 I can put, this is 1, this is 2, etc. minus 1. Then they all will be written like this. Can we do something similar with our plane polar coordinates? How do we do that? So if I have, this is my origin. So what is, instead of x and y, I should say rho and phi. So what will be, rho is equal to constant lines. Rho is equal to constant means what? From the center, rho is the position vector, the radius vector. If it is a constant, if I move along all the locus of all the points which are having same distance from the origin, you know it will be a circle. We all know that circle has got constant radius. So rho is equal to constant. If I have unit 2, that will be a bigger circle or still bigger circle. So these are rho is equal to constant lines like here. Then what about phi is equal to constant? If the phi is constant, this will be phi is equal to constant. Similarly, I can have one more line, phi is equal to constant. Phi is equal to constant. All of them are phi is equal to constant. So you find just as you have x equal to constant, y equal to constant line, similarly you can observe rho is equal to constant, phi is equal to constant here. So this is important to remember when we go ahead. Now let us try to obtain some simple relationship we have written. Before I doing that, I should perhaps justify why you want a plane polar coordinate. Why do you want a plane polar coordinate? Let us take the simple example. What is the example? I want to find the area of a circle. I want to find the area of the circle. Now let us find out what is a elemental area from delta x, delta y. You know, that is a elemental area here. If I take any one of the small square, this is delta x, this will be delta y. See, this area is delta x into delta y. So this is the elemental area. Now if I get to the limit that delta x and delta y tend to 0, then the elemental area, for example A, which is a vector, we all know that, is nothing but dx dy into n, where n is a unit vector normal to the surface, because it is a vector. So you find A is the elemental vector in rectangular coordinate system is dx dy, and it is in the direction of n. Can I get something similar with my rho phi? How do you get that? So for that, this is phi. So I will take some small delta phi, and so I will take a small elemental area. This distance is d rho, and what is this distance? This angle is delta phi, this length is rho, so this distance is rho d phi. So the same elemental area will be rho d phi in the limit delta phi going to 0, rho d phi, that is a length. I will magnify it. This is my rho, this is my delta phi, this will be my rho plus delta rho. So that is what it is. In the limit delta phi tending to 0, this is almost taken as a straight line. This will be also in this direction. So this will become almost like a rectangle or square, and therefore this distance is rho delta phi r theta, right? That will be the thing. This is 0. So we have to multiply by 0. So my elemental area, I will call this dA preferably, small area. The elemental area is equal to rho d rho d phi. Okay, you should read it as rho d rho d phi. You should not read it as rho d phi. No, this is d rho. This is d phi. So there are only three quantities: rho, d rho, d phi. Now I get the elemental area. I can find what is the area of a circle. So what I should do? Simply integrate this. So area of a circle, I will do here. Area of is equal to integral I should find out rho. What is the range for rho? We have already seen that. Rho can go from area of circle of radius r, let us say. Then rho can go from 0 to r. That is the range for rho, radius vector. And there is one more, d phi. Not only rho d rho, you have d phi also. What is the range for phi? We have already seen. The range for phi, if I want the whole thing, is 0 to 2 pi. So you find there are two limits. One 0 to r, the other one 0 to 2 pi, and I should write the elemental area rho d phi. I have to now integrate this. You can immediately see this does not contain phi, so 0 to 2 pi is only for that. That will give me a 2 pi when I integrate. This becomes phi. Phi has got 0 to 2 pi, therefore the value is 2 phi. Rho d rho gives me rho square by 2 in the limit 0 to r. So that will be r square. So this will be by r square. This 2 and 2 will cancel. So this will be my r square. So pi r square I get in a very, very simple straightforward manner when I use this. The same thing you try using dx dy. You would find how difficult it is. Therefore, you find this plane polar coordinates helps us to solve some of the problems much more easily if the symmetry of the problem matches with the plane polar coordinate. That means it should have circular or elliptical or some such cylindrical, some such shapes. If it have, you would find you require a different frame of reference than what we normally use as rectangular coordinates, and that is why we are discussing this. Okay. Now I have to go forward and obtain what is the radius vector. We already saw that. We saw that the radius vector, no, position vector, sorry. The position vector in this is rho along the EO. So once I know the position vector, I will call this using the standard symbol r. Then I can find out what is dr by dt. What this will give me? This will give me velocity, which I can write it as r dot. This dot means differentiation with reference to time. I already mentioned to you. So dr by dt can be represented simply by r dot, and that is v. Then I can also do one more. That means I can do dv by dt to get acceleration. And that is equal to r double dot, because you know d square r by dt square, that is nothing but r double. So we will try to obtain from this and this. That is what we are going to do next class. We are going to discuss how this phi changes with reference to time when I differentiate with reference to time. When I differentiate ex, ey with reference to time, it is 0. They are not changing. They are constant, ex and ey, once I choose a particular x and y. Whereas here, because rho is changing, e rho will also change, e phi will also change. So both e rho and e phi will be functions of phi, angle phi, and therefore that makes slightly more complicated than the normal, but you would find it is not very difficult. We can derive expressions for that in the next time. But I want to spend the rest of the time to discuss any problem. I never had occasion to get some points from you. Any doubts or comments you want to make? Now is the time on any of the topic that I discussed so far. Even earlier lectures, if you have been attending, you can ask. Most probably all these videos, and if possible, I will also upload some slides for you, which gives you an overview of the various things that we have discussed. That also will help you. And I already told you the importance of solving problems, applying the knowledge. Whatever knowledge we gain, we must be able to apply. That's the most important thing. There is no point in asking you derive the expression for E phi and E rho. That is not important. I have already done it. You have seen it. There is no point in again repeating it. Rather, I would say how to apply to a new situation in solving problems. Therefore, solving problem is very important. I will upload a problem sheet maybe this week or next week, and I would like you to attempt some of them, and then we can discuss, or your teachers will discuss in your classroom at some leisure. Okay. Now, please feel free to ask any questions based on whatever I have covered over these 3 or 4 lectures. We have some short time. Any question, please?
Good morning, sir.
Yes.
No? Sir, I would like to know that.
Go ahead. Otherwise, you come in the chat mode if we are not able to get the audio.
Hello, sir.
Yeah, they have to switch on the audio. You have to switch on the mic. Check whether the mic is on.
Hello. Hello. Sir, I would like to know the difference between a phasor and a vector. Phasor and a vector, sir. Hello.
There is only one question. Anybody else? In the meantime, the best thing is to type it in the chat mode. Okay. If you can type it in the chat, because I am not able to hear you. You can also send me email. Both are possible. Make a note of my email. Send me all your doubts. I love them. I enjoy. Yes.
Hello, sir. How did you write that magnitude of U rho cap is equal to cos pi?
Hear you.
Hello.
Yeah.
Are you able to hear me, sir?
Is there a chat mode?
Hello.
Phasor and a vector. Okay. Is there a difference between a phasor and a vector? Phasor, I mean, in this case, this is more like a phasor. The rho is something like a phasor, no? The phase also continuously changing. Okay. Whereas a vector has got magnitude and direction fixed. A phasor is capable of rotation, and therefore the phi can change. So the rho phi that I will talk about here is like a phasor. Okay. That will be the difference. Then okay, as I said, I am going to help you to learn some tools, especially in mathematical tools, which are very, very useful to you. In my problem sheet, I will try to give problems which have got relationship with physics. And therefore, as engineers, if you have a good background in these tools, you would find they will be very, very useful later in electrical engineering or mechanical engineering or any other topic. That is why I try to put them together and give it to you rather than give some standard topics like semiconductor physics, superconductivity, electromagnetic theory, etc. For all of them, this basic physics will be a great support to solve problems and become better engineers. That's the ultimate aim. And more importantly, helping you to apply your knowledge in solving problems. That is the most important part of the whole discussion that we have here. That is a major difference with most of the time between many engineering institutions and the IITs. Here, it has to be problem, and we have to apply problem sheet and then students should be encouraged to apply their knowledge to new situations. When they become later on great science engineers, they'll be able to design innovative things only if you have got enough confidence. Is that okay? Is there anything, any other question if you want to ask? Please feel free to ask questions. Asking questions is more important than answering them. Okay? I will try to answer as many questions as possible. Even otherwise, you use this email and send me your questions. I'll try to answer. Yes, sir.
Sir, I gave you a question.
Please.
Sir, in the derivation part, you can mention that magnitude of u rho cap
Yes.
is equal to cos pi.
Yes.
How did you get that one, sir? Because u rho cap is equal to cos pi ex direction plus sin pi ey direction. But you are saying that the magnitude of u rho cap is equal to only cos pi.
Yeah, I have not perhaps. Yes. Good point, sir. Very good question. Because I don't know how I wrote it. The correct thing, as you said, is cos phi x plus sin phi y. So this is what I should have written. Exactly what you are saying is right. This is x by root of square plus y square, x plus y by square plus y square, y. Sorry about this. That is wrong. What I wrote was wrong. This is the correct. This is the full expression. Good that you pointed out.
Thank you, sir. Thank you so much, sir. Thank you, sir.
I missed that point. Good. Thank you very much.
Thank you, sir.
Same way I can write E5. The same way. Minus sign. This is the correct full expression. Okay? I should have written it like that. What I wrote that time is wrong. Thank you.
Thank you, sir. Thank you.
Any other point? So it can always happen here when I write. For some reason, some excitement, I will miss some point. Okay, it is good that point out. Thank you very much.
Thank you, sir. Thank you.
Other point? So as I said, if you are not able to get the audio across, don't worry. I like questions. I want people to ask as many questions as possible. If you have got any questions, please send it across this email. I'll try to explain. It can be the silliest question. I like silly questions more than anything else. Okay, because there is nothing like silly questions. A great Nobel laureate and a great teacher, Richard Feynman, when he walks into the classroom, he will bring lot of chocolates. He will throw to all students who ask silly questions. Right? Because there is nothing like silly. What is silly to somebody can be a very profound question for another guy. Because so many minds are looking at things. Each one will have a different perception, way of understanding. So it is important at the time of understanding, whatever doubt you get, immediately you post it across so that we'll try to explain. Thank you very much.